Hi folks! Over the past couple classes, we've talked about different kinds of descriptive statistics. To be exact, we've talked about three different measures of central tendency: mean, median, and mode. And we've also talked about three measures of variability: range, interquartile range, and standard deviation. In this short video, we're going to see how to calculate those descriptive statistics very easily using SPSS. And the first thing to know is that the process will be slightly different depending on whether we're working with a categorical variable or a continuous variable. If we wanted to get descriptives for a categorical variable, something like religious affiliation, for example, we're going to do the same thing we've done previously when we wanted a histogram. And that is go to Analyze Descriptive Statistics Frequencies. We will see a list of all of our variables on the left, and we're going to select the variable we're interested in and move it over to the box on the right. So in this case, I've selected religious affiliation. If I were to click OK right now, SPSS would show me a table of all of the different religious affiliations that were options in our survey, the number of people who selected each option, and the percentage of people who selected each option. So we could easily figure out, for example, what percentage of people are Jewish, what percentage of people have no religious affiliation, and so on. Using that, we could also very easily spot the mode, right? The category that has the most people in it. But that's really all we can do for a categorical variable, is report the mode. Remember, we can't calculate a mean or a median or a standard deviation of a categorical variable. It just doesn't make any sense. With a continuous variable, however, there's a lot more that we can do. So if I was interested in something like how long it takes a person to get to work, the length of their daily commute in minutes, which is a categorical variable, which is a continuous variable, here's where I would go to do that. Analyze descriptive statistics, and then right below where we just were, we're going to select the option called Explore. Explore is the procedure we're going to use when we want to calculate descriptive statistics for a continuous variable, such as how long it takes a person to drive to work. In the Explore menu, you will again see on the left-hand side a list of all of the variables that we have, but there are now three boxes on the right-hand side. We're going to use the top box, the one called Dependent List. So whatever continuous variable we're interested in, we're going to select it from the list on the left. We're going to move it into the dependent list box on the right. Then we're going to click OK. And what we will see appear in our output is a whole bunch of information about that continuous variable. So this table at the top left, for example, reminds us that there are a total of 360 people in this data file. This is census.sav, by the way. I probably should have mentioned that earlier. We have responses from 360 people, all of whom answered this question. In other words, we don't have any missing data in our file. In the table below, we see descriptive statistics for this variable. Highlighted in green are things that we've talked about previously in class. So in this sample, the mean commute time was 25.22 minutes. Notice how I rounded that number to exactly 2 decimal places, 25.22 minutes. In other words, the average person in our sample takes about 25 minutes to get to work. Below that, highlighted in green, we see the median, which is actually also 25 minutes. So in this case, the mean and the median are very similar to each other, which suggests that we have a symmetrical rather than skewed distribution. We also get all three of our measures of variability here. So there's your standard deviation here would be 9.63 minutes. So we could use the empirical rule to determine, the commute length for 68% of people would be 25.22, our mean, plus or minus 9.63, our standard deviation. That would capture the commute times of the majority of our sample. We also see our range, which is 53 minutes. Right above that, it tells us the shortest and longest commute times. So there's at least one person in our sample who has a 0-minute commute. Presumably they work from home. There's at least one person in our sample who has a 53-minute commute, hence the range of 53 minutes. We also have our interquartile range, which in this case is 14. Remember, that's the difference between Q1 and Q3. If we look over to the right on our box plot, we'll see most of these numbers represented visually. So again, the thick line in the middle of our box, that's our median, which is at 25. The top of our box is going to be our Q3. So just from eyeballing it here, it looks like our Q3 is about 32 minutes. The bottom of our box is our Q1. Again, I'm eyeballing that. It looks like it's about 18 minutes. The height of our box is going to be our IQR. So we know that the IQR is 14 minutes, so our box is 14 minutes tall. In this case, it looks like we don't have any outliers in our sample because we only have whiskers on our box plot, but we don't have any dots on our box plot. So that's a quick way of finding out that we don't have any outliers here. Instead, the lowest commute time was 0 minutes, so that's where our bottom whisker ends. And our longest commute time was 53 minutes, so that's where our top whisker ends. The last thing I want to bring to your attention is something that we haven't talked about previously. So we've talked about symmetrical distributions and we've talked about skewed distributions, but we haven't talked about how to determine when a distribution really is skewed. How do we know if it is skewed to an extent that is maybe problematic or concerning or just worth knowing about? At the bottom of the descriptives table, you'll notice I have two numbers highlighted in orange. Those are what are called the skewness statistics. Now, I'm not going to get into detail about what exactly those are telling us, but we can use those two numbers that are highlighted in orange to determine whether our distribution is skewed or whether it is symmetrical. Here's how we do that. All we have to do is take the number on the left, in this case 0.053, and divide it by the number on the right, which is 0.129. Once we divide that, we're going to ask ourselves, does that number fall within the boundaries of plus or minus 3? If we end up with a number that's anywhere between plus or minus 3, we're going to say that our distribution is symmetrical. If we end up with a number that is less than -3, that tells us that we have negative skewness or a negatively skewed distribution. If we end up with a number that is larger than +3, we would say that our distribution is positively skewed. In this case, when you divide out 0.053 divided by 0.129, you will get a value of 0.41, which of course is between plus or minus 3. It's very close to 0. Therefore, we can conclude that the distribution of daily commute times in our sample is not skewed. It is symmetrical.